Do atoms versus ions. So we're going to look at the ionic compounds. So the first thing we've got to do is differentiate. Atoms are neutral. That means that the number of protons has to equal the number of electrons. Okay? Which really means that the number of positives equals the number of negatives. So to be neutral, we have to have a zero charge. Okay? Ions, on the other hand, are charged species. And they are charged because they gain or lose electrons. So they have a charge. Cations or cations are positively charged. Positively charged. So they're designating with a positive because they have lost electrons. They lose electrons or they've lost electrons. And remember, electrons are negative, protons are positive. So if you lose electrons, you're left with extra positive. Anions, on the other hand, are negatively charged. So they're negative. And so you've gained electrons. Because electrons are negative if you have more than if you had 10 positives, 10 negatives, and you added 2 electrons, then you end up with the 12 minuses minus 10 positives is 2 minus. Monoatomic means there's only one atom involved. Polyatomic means there's more than one atom. So, for example, sodium plus would be monoatomic chloride minus, whereas ammonium ion is a polyatomic positive, whereas this perchlorate is going to be negative. More about the naming as we go to it. So that's where we start with the ions. Now, ions are relatively simple in terms of the elementals because they're easy to ID on the periodic table. So metals tend to form positives. Okay. So cations, remember, are positively charged. They tend to be metals. Anions are negatively charged, which means they've gained electrons. So those tend to be nonmetals. And when you look on the periodic table, this is the goal. The goal is to reach noble gas. So for positives, it's easier to lose one to go backwards. So this is group 1A. So this tends to be 1 plus. Group 2A tends to be 2 plus. 3A is 3 plus. And then here you switch, because you can either gain or lose 4 electrons. And so nitrogen goes negative because it's trying to get to the noble gas by gaining 3 electrons. This one is going to gain 2 electrons, and this one's going to gain 1 electron. And if you'll notice, hydrogen appears as a +1 and a -1 because it acts both ways. A lot of periodic tables put it in the center because it tends to kind of do its own thing. Now, as to why we're going to noble gas configuration, we will get to that later. But just if you look at it on the periodic table, this is 1 plus, 2 plus, 3 plus. This is 4 plus or 4 minus, 3 minus, 2 minus, 1 minus. And then the noble gases, remember, do not like to play. Okay? So that brings us to how do we count the protons and the electrons. Okay? So for chromium 3 plus, if we look on the periodic table, chromium has 24 protons, which means in a neutral species, it would have 24 electrons too. But we're up 3 positive, which means we lost 3 electrons. Okay? Because 21 plus 3 is 24 negatives. Okay? And these are 3 electrons lost. So that's how we count the electrons. In this case, sulfur has gained 2 electrons. Okay, we could say we lost 3 electrons. So if we look where sulfur is on the periodic table, it has 16 protons. Its atomic number is 16. So if we gain 2 electrons, then we have 18 electrons. All right, 10-4, we lost 4 electrons. And so if we look at the atomic number of 10, it's 50. So we have 50 protons. And remember, when we form ions, we're never going to lose and gain protons. That's radioactivity. There's one chapter later on that we may or may not get to in 1212, but we're going to look at electrons because that's what goes on in chemical reactions. So we lost 4. We should have started with 50, so we're going to go to 46 electrons. So with the ions, we figure out how many electrons we've either lost or gained. Now, why is this important? This becomes important because that's how we combine ions to form compounds. So there's some rules to ionic compounds. First off, ionic compounds are composed of ions. That's because you're gaining and losing electrons to form ions, which then come together to have the charges attract, just like south and north poles of a magnet. In an ionic compound, the total charge on the ions, the cations, has to equal the anions. So overall, we have to have a neutral charge. So our positives have to equal our negatives. The compound is written with the cation first and then the anion second. The generic term for an ionic compound is the 4-letter word beginning with S, which is a salt. So if we look at it, calcium is 2+, but fluoride is 1-. So in order to make them balance, because what we have to have is the 2+ has to equal the 2- so that the compound is neutral. So when it combines, we're going to have 1 calcium plus 2 fluorides to form calcium fluoride. Because notice, it should have a 0 up here. We don't write the 0, but it's assumed if there's no charge written to be 0. All right? So those are the basic rules for producing ionic compounds. There are a few little ones as we go. We're going to work on those as we work some problems. So here's the first one. We have a 3+ charge here. We have a 1-. So in order to make them equal, we're going to need 3 of these chlorides. So cation's written first, so we'll do FeCl3. So that means that we have 1 iron, that's not chloride, iron, and 3 chloride ions combined, once they combine. Now here I've given you a 3-, and this is a 1+. So in this particular case, we're going to need 3 of these and 1 of those. Now, the rule says that the positive has to be written first. Now, when I gave it to you, I gave you the negative first. Is that a problem? No. Okay. So, but we're going to write it with the ammonium first and then the nitrogen second. But I need 3 ammoniums. I can't write a 3 there unless I put it in parentheses. So, more than 1 polyatomic, you put the ion in parentheses. Because notice up here, chlorine is a monoatomic, so it doesn't have to have any parentheses. But polyatomics, if there's more than 1 of them, gets a parentheses. Okay, so this indicates that there are 3 ammoniums. So that also means that in this compound, here you're going to have 3 nitrogens plus 4, no, 12. See, if I could do math, life would be better. So you would have 12 hydrogens. More about that as we go. But remember, positive first, then negative, and polyatomics go in parentheses. All right, so here we have chromium 3 plus, and we have 2 minus. So the question is which number will they go into the smallest? It's a 6. That means you're going to need 2 chromiums plus 3 oxygens to produce Cr2O3. Okay, again, it's a neutral compound. Now, some of you may have encountered this before, and they'll tell you just take the charge and assign it to the other one. So this is a 3 plus, so the 3 will go here and the 2 will go here. That works a lot of the time if they're not comparable. But let's come over here and let me show you an example. So if I have 10 4 plus oxygen 2 minus, if I were to just exchange those, then I'd have 10 2 O 4. That doesn't exist. So in this case, the smallest number that they both will go into is 4. So the formula for 10 in oxygen is SnO2. Okay? So the trick on this one is if you've been told to just take the valence numbers and flip them, don't do that because it'll get you in trouble. Now, in this particular case, we have this whole thing is only 2 minus, and this one is 1 plus. So we're going to need 2 of these and 1 of these. And again, the positive has to come first, so it's K2CrO4. Now, if you'll notice, potassium is a monoatomic, so it got a 2. And before, when we had 3 ammonias, we put a parenthesis around it because it was a polyatomic. So the chromate is your polyatomic, but because we only have one of those, no parentheses if only one. Okay? Now, manganese here is 5 plus. Arsenic is 3 minus. The smallest number those will go into is 15. It's the smallest. So we're going to have 3 manganeses plus 3 arsenates. And again, you don't know the names yet. We'll get to a lot of them. So it's Mn3AsO4. Wait, that one's 3. This one's a 5. That's what erasers are for. And we have a 5 here, so we have a 5 there. Okay? So notice that this one is a monoatomic. So it has no parentheses. This one is a polyatomic. And you have more than one, so you get parentheses. Okay? This is actually pretty critical because in naming or producing compounds, if you make it fussy or you change it, for example, H2O2 is not the same thing as H2O, you have to be very careful because it changes the compound. Okay, so those are the ionic compounds. And these are very common in living organisms. So this little lanyard talks about the elements that appear in biological systems, aka you, etc. So in the next section, we're going to look at types of species so that we can do oxidation numbers to get to naming.